This LOS is calculate and interpret net present value, NPV, internal rate of return, IRR, payback period, discounted payback period, and profitability index of a single capital project. Net present value. For this section, I just wanted to take a screenshot of the textbook exactly just to show you the little example that they have in the text. It has some fairly simple numbers. Just wanted to show you where that came from. I'm going to use it on the example and use my calculator later on as well. So net present value. For a project with one investment outlay made initially, the net present value is the present value of the future after-tax cash flows minus the investment outlay. So they're giving you the equation there. It's the sum of the cash flows that are discounted minus the outlay. So CFT equals the after-tax cash flow at time t. R is the required rate of return for the investment, and the outlay is the investment cash flow at time zero. So the example that they have in the text is to illustrate the net present value criterion. They'll take a look at a simple example. Assume that Gerhardt Corporation is considering an investment of 50 million euros in a capital project that will return after-tax cash flows of 16 million euros per year for the next 4 years, plus another 20 million euros in year 5. The required rate of return is 10%. So for Gerhardt example, the NPV would be the sum of the present value of 16 million discounted at 10% for 4 years, plus the 20 million discounted at 10% in the 5th year minus the 50. So we can see they've done the algebra there. The NPV equals 13.136 million euros. Okay, so the example in my slides is basically using the same numbers, but I took out, I made it only a 4-year example, so I took out one of the years with plus 16, and so I shortened it so we can show the calculator keystrokes in the next slide, okay? So here's basically the same example. We have the initial outflow of minus 50, and then we have an inflow of 16 million for year 1, 16 million for year 2, 16 million for year 3, and in year 4, a final after-tax cash flow of 20 million euros, okay? So we do the present value for each cash flow at 10%, discounting at 10%. So 16 million discounted at 10% for year 1, 14.54. 16 million discounted for 2 years, 13.22. For 3 years, 12.02. And then finally that 20 million discounting back, if you do the algebra, is 13.56. You add them all up together, you get 53.4499 minus the initial outlay, so you get an NPV of 3.4499. It's above zero, so you would do it. The investment criterion is invest if the net present value is greater than zero. Do not invest if the net present value is less than zero, because you're not going to add any value. So just a quick screen grab again from the text. You can see from the Gerhardt example that the investment has a total value or present value future cash flow of 63.136 million euros. Since this investment can be acquired at a cost of 50 million euros, the investing company is giving up 50 million of its wealth in exchange for an investment worth 63.136 million. The investor's wealth increases by a net of 13.136 million. Because the net present value is the amount by which the investor's wealth increases as a result of the investment, the decision rule for the NPV is as follows. Invest if net present value is greater than zero, and do not invest if net present value is less than zero. Positive net present value investments are wealth increasing, whereas negative net present value investments are wealth decreasing. Many investments have cash flow patterns in which outflows may not occur only at time zero, but also at future dates. It's useful to consider the NPV to be the present value of all cash flows, okay? So here we're just going to review the math a little bit. So there's 3 ways of solving a net present value question, okay? The first way is to use the algebra, and I won't run through that in too much detail because that'll be too time consuming. But we're going to add up, first of all, the cash flow zero is a negative, so that's going to be a negative. And then we're just adding up the present value of all the cash flows, okay? So for example, if we looked at the year 4 cash flow, which is a 20 million euros coming in 4 years from now, then of course the formula would be the 20 million divided by 1 plus 0.10, because it's 10%, to the power of 4, okay? And that's the algebra. Now, a second way to solve it is to do the present value of each of the cash flows using the time value of money functionality on the calculator. So if I bring up my calculator here quickly, we can use our time value money functionality. So the first, I'm just going to check that we're set to 1 period per year. Yes, we are. So for the first one, it's 1 year from now. The interest rate, discount rate, is 10%, and there's going to be no payment, and we're going to receive 16 million in the future. So we're going to compute the present value, and I've got 14.54545. So that's correct. Okay. Now the second payment is the exact same amount. So just calculator keystrokes to save time. I could do 2n and compute present value. I've got 13.22314. Okay. So speed is a skill. Skill gets rewarded. I can do this one very quickly. I can do 3n and then compute the present value. I've got 12.02104. That's fine. And then I could do my 20 for my future value, and that's going to be 4 years in the future, and I'm going to compute my present value, 13.66027. Okay, so I'd add up all those. I'd have to write them down. That would add up to 53.4499. Subtract the 50, the initial outlay. I have a net present value of 3.4499. Okay, so that's the second way that we can calculate, is use the time value of money functionality on the calculator and calculate the present value of each of the cash flows, add them up, subtract the initial outflow, and there you go. Okay, but another functionality on the calculator is here, the cash flow, NPV, and IRR, and that's very important for this section of corporate finance. So I can hit the cash flow key. Oh, I've got something in there from before, so I can click second, clear my work, and I'm going to reset everything to 0. Okay, so this one, I'm going to hit cash flow. The initial cash flow 0 is 50, and it's a negative, and I'm going to hit enter. Okay, then I'm going to arrow down, and I'm going to enter my first cash flow, which is 16, enter it, and then I get here F, that's frequency. Well, I can take a little bit of a shortcut here because it's the same cash flow 3 times. So I can hit frequency 3 and hit enter. So now I've got frequency for that 16 cash flow as 3 times. Okay. So then it's saying C2. It's not really the second cash flow. This is the fourth year 4 cash flow, but it's going to be the 20, and we're going to hit enter. We go to the NPV key. We're going to put in 10 as the interest rate, enter. Then we arrow down, and don't worry if you arrow down or arrow up, you're going to scroll through the same choices. But I arrow down and I hit compute, and there I've got my NPV of 3.4490, exactly the same, using the cash flow and the NPV. If I wanted to click on the IRR, calculate the IRR, which I haven't done in this example, I just click on IRR, I'd hit compute, and it's going to be 13.04169, which is higher than my 10%, because the IRR is the discount rate that gives me an NPV equals 0. I have an NPV, a positive NPV, 3.499, using a 10% discount rate, so the IRR is going to be higher. So if that was just a little bit too quick for you and you're still working on getting your calculator skills up to speed, I just have a couple of slides here just to show you the steps. So you can see I'll bring up the calculator again. And so to clear previous work, I'm going to do press my cash flow, and I'm going to do second, and then clear work, which is above the CEC key. Okay, so I just hit that, and I've cleared it. And then the CFO, if I go to my cash flow, it's displayed as 0, and then you're going to enter the period 0 cash flow. If it's an outflow, you got to hit the plus or minus key to change the sign. So in that example, the initial outflow was 50. We need to hit the plus minus key, and then we're going to hit enter again. Okay, so I'm just going through this a little bit slowly so that if people are still back in the quants, you should be getting up to speed on the calculator. But if you're doing corporate finance, sometimes it's good for a little bit of a review. Okay, so to enter each figure in the cash flow register, you hit enter, as I said. So carrying on now with the calculator tips, then you're going to press the down arrow to move to the next cash flow register. And as I said before, just think of this as entering something in Excel, and you're just clicking down through the rows, okay? So enter the cash flow amount, press enter, and then down arrow to move to the cash flow counter, which is the frequency, okay? The default on the frequency counter is 1. To accept the value of 1, just press the down arrow again, and to change the counter, enter the correct count, plus enter, and then the down arrow again. So I'm just going to bring up the calculator again. So just leave where we left off. So we can see our initial cash flow was 50, outflow, and then we click down, and it's going to take us to that first cash flow right away. So we're going to hit 16, and we're going to hit enter, and we're going to arrow down, and there's that frequency again. And we knew that in this case, we had 16 million for 3 years. So we're going to click 3, and we hit enter, we arrow down, and we get to the next cash flow, which in that case, just finishing it again, was 20. We're going to enter, and then if we went to the NPV key, we'd put in the interest rate of 10%, hit enter, arrow down, and we'd hit compute 3.4499. So carrying on, we would repeat for all cash flows in order. And then to find the NPV, as I said, you press NPV, I appears on the screen, you enter the interest rate, you press enter, then arrow down to display the NPV, and then you press compute, okay? And then to find the IRR, you just press the IRR key, 000 is going to appear on the screen, and you're going to press compute. So let's just bring up the calculator again. Now in this case, I may want to just change it to be exactly what was in the text. So I can go to my cash flow register, okay? -50 was my outflow. I had 16 million, but the frequency on this was 4 times. Remember, I shortened it for my example. I'm going to change that to 4 times, arrow down, and my last cash flow was 20, okay? So then I'm going to click on my NPV, interest rate is 10%, arrow down. This has my old answer. I changed it from 3 years to 4 years. That's 16 million euros coming in. I'm going to hit compute again, and I've got the 13.13627, which is the exact same number in the text. That's the wealth that I have created from the project. Don't want to spend a lot of time on the slide, but it's just got the calculator keystrokes written out for you, just in case you want to follow it step by step in writing and not listen to the video. So again, just very quickly, I'm going to hit cash flow. I'm going to I'm going to clear my work, so we'll just do it. So then I'm going to hit my cash flow again. You can see CF0. I'm going to do 50 plus or minus, hit enter, arrow down. So I'm showing you enter, arrow down. I'm going to do 16, enter, arrow down. In this case, I'm entering 16 3 times. If the cash flows were different, you would enter each one individually. So just a quick practice here. C2 is 16, enter, arrow down, frequency is 1. C3 is 16, enter, arrow down. C4 is my 20. I'm going to enter that, okay, arrow down. And so the next thing that I'm going to do is I'm going to click on my NPV. The interest rate is 10, enter, arrow down, and I'm going to hit compute, and I've got my 3.4499. I hit my IRR, and I hit compute, and there's my 13.04169. Okay, this slide's just a little bit of fun, so it's just going to stress again the point on the IRR. So the decision rule for independent projects is accept all projects if the IRR is greater than the cost of capital, the hurdle rate, and positive NPV. Okay, so what I've done here is I've just taken the same cash flows, but I've changed the discount rate on my NPV calculation to equal the IRR that we computed previously. And I just wanted to show you that the IRR is the discount rate that makes the NPV 0. Okay, and I can just show that if we go to here, NPV key, and I'm going to change that from 10% to our 13.04169, and I'm going to hit enter, okay, and then I'm going to arrow down, and I'm going to hit compute, and I get my 0. So again, the IRR, okay, the internal rate of return is the discount rate that gives me a net present value equals to 0. So a practice question to check our understanding. A project has the following annual cash flows. In time 0, we've got negative $606,061. Year 1, we've got $2,151,515 positive. Year 2, so this is a non-conventional cash flow. We have another negative of negative $2,542,424. And then finally in year 3, we have a positive inflow of $1 million. So which discount rate most likely provides a positive net present value? Is it A, 15%, B, 18%, or C, 21%? Okay, this is a bit of a tricky question, and the reason is because we have non-conventional cash flows. We can see that here in year 2, we've got this negative, and so that changes things. Because normally, as we know, as we increase the discount rate, we're going to decrease the net present value. So most students, if they just guess on this, they're going to guess A, because that's the lower discount rate. It's going to give the biggest net present value if we're using conventional cash flows, where there's an initial negative outflow followed by all positive. But in this case, it's a non-conventional cash flow, so that changes it. So you can see here, here's the table, which is just there for you FYI. There's your year 0 cash flow, year 1, year 2, year 3. So if you do the calculations and you discount everything at 15%, you're going to get a negative net present value of negative 100. If you discount at 18%, you're going to get a negative NPV of negative 41.7, and it's at the 21% discount rate is the only one that gives you a positive net present value. So you can see 90 seconds, it would be very difficult to crank through all these calculations, 1, 2, 3, 4, 5, 6, 7, 8, 9, add them all up, etc. So you can use the cash flow functionality on the calculator fairly quickly. So what would we do? We'd go to our cash flow. Okay, it's cleared. Just to be better safe than sorry, though, hit second clear work. So now I know it's cleared for sure. And then we'll do 606061, and that's a negative. Enter, arrow down. The next cash flow is 2151515. That's a positive. We're going to hit enter. Frequency on that is 1. The next cash flow is the 2542424, and that's a negative. Got to be very careful. Hit that plus minus key. Going to hit enter, arrow down. Frequency on that is 1. So when we get to our last cash flow, which is cash flow 3, year 3, that's $1 million, and that's a positive. We're going to hit enter. So we're going to hit the NPV key. So this is the quicker way to do it. I'm going to hit 15. I'm going to hit enter. I'm going to arrow down, and I'm going to hit compute. Negative 99.96. So you can see we rounded it to 100 there. Okay. Then I can arrow just back up. I can change the interest rate to the 18%, hit enter, arrow down, and hit compute. Whoa, I'm still at my negative 41.66. Arrow back up, interest rate, I'm going to hit my 21. I'm going to hit enter, arrow back down, I'm going to hit compute. Voila, I've got 14.69, which is my 14.7. That's the only positive one. It's C. So speed is a skill. Skill gets rewarded. You could see I could do that on the calculator in less than 90 seconds for sure because I've practiced. I entered the cash flows, and then I just arrowed back and forth between entering the discount rates from 15 to 18, 21, compute the net present value. You just have to be quick. You have to practice. Okay, so we finished with the net present value and IRR. Now we're moving on towards the payback period and the discounted payback period. And this is a fairly easy topic, and we see this at undergraduate college level all the time. So this should not be new to most CFA candidates unless you're coming in from non-business background. Okay, so here on the top row, we've got our cash flows. So we can have our initial outflow is negative. We've got 20,000. And then we have positive cash flows coming in of 5,000 year 1, 5,000 year 2, 6,000 in year 3, 6,000 in year 4, and 6,000 in year 5. So we need to calculate the payback. How do we do that? On the next row, we've got our cumulative cash flow. So 20,000 went out, 5,000 came in. So that's a cumulative of 15, negative 15. Okay. Negative 15 plus 5 is negative 10. Negative 10 plus 6 is negative 4. Aha, we can see that negative 4 plus 6, we've got a positive 2,000. So we know our payback is after year 3, but it's before the end of year 4. So how do we calculate the part year? All we do is we see that we had at the end of year 4, 2,000. So we do 2,000 divided by 6,000 times 12 months in a year. We get 3 years and 4 months, okay? Since the cash flows are not discounted at the project's required rate of return, the payback period ignores the time value of money and the risk of the project. Additionally, the payback period ignores cash flows after the payback period is reached. Okay, so these could all start to be very negative, but it's ignoring it. It's just saying, hey, we get paid back in 3 years and 4 months. Okay, so now we're going to look at the discounted payback period, and we're going to use an interest rate of 10%. So we're using the same data as the previous slide. Here we have the cash flows, negative 20,000 times 0, then year 1 plus 5,000, year 2 plus 5,000, year 3 plus 6,000, year 4 plus 6,000, year 5 plus 6,000. So our cumulative cash flow, we saw that in the previous slide, negative 20,000 plus 5,000, negative 15. Negative 15 plus 5, negative 10. Negative 10 plus 6, negative 4. Negative 4 plus 6 equals positive 2. So we know our payback period was more than 3 years, but less than 4. So how do we calculate that? It was 2,000 divided by 6,000 times 12. That gives us 4 months. So it's 3 years and 4 months. Then finally finishing off 2,000 plus 6 gives us our positive 8. So that was our cumulative cash flow, okay? But we're not going to look at that row anymore, because what we're going to do is we're going to discount these cash flows, and we're going to use 10%. So 5,000 discounted 10% for 1 year is 4545. 5,000 discounted 10% for 2 years is 4132. 6,000 discounted for 3 years is 4508. 6,000 discounted for 4 years at 10% is 4,098. And finally, 6,000 discounted for 5 years at 10% is 3726. So we're just going to go through the same, that's our discounted cash flow. We're going to go through our cumulative discounted cash flow, so it's the same. Negative 20,000 plus 4545 is negative 15,455, plus 4132, negative 11,322, plus 4508, negative 6814, plus 4098. We're still at negative here in year 4, negative 2716, plus our 3726. We're going to get 1009. So we can see now our payback is after year 4, but before the end of year 5. So we just go through the same example here. It's going to be the 1009 divided by 3726 times the 12 months equals 4 years and 3.25 months. If you needed it to put into days, if they gave you the question in days, you would just do the same thing. 1009 divided by 3726 times 365, and then you'd have the number of days, okay? So the discounted payback does account for the time value of money and the risk within the discounted payback period, but it ignores cash flows after the discounted payback period is reached. This drawback has 2 consequences. First, the discounted payback period is not a good measure of profitability because it ignores these cash flows. Second, another idiosyncrasy of the discounted payback period comes from the possibility of negative cash flows after the discounted payback period is reached. So you could have a bunch of negative cash flows happening out here. You'd say, hey, it looks like a great project, but because the payback is a short period of time, but then you run into a bunch of negative cash flows, okay? So it's possible for a project to have a negative NPV, but to have a positive cumulative discounted cash flow in the middle of its life, and thus a reasonable discounted payback period. And now we're going to finish this LOS with the Profitability Index, okay? So this is an important formula that you need to memorize. So the Profitability Index is, they're giving you the 2 formulas. Firstly, it's the present value of the future cash flows divided by the initial investment, which is the same as 1 plus the net present value over the initial investment. So just going back to my example that I used, we had a net present value of 3.4499. So the profitability using the net present value, 1 plus the net present value over the initial investment, 1 plus 3.4499 divided by 50 gives us 1069, which is the same thing as the present value divided by the initial investment, which was 53.4499 divided by 50. We have a profitability index of 1.069. So obviously, because the initial investment is in the denominator, we want a big numerator, very profitable projects. So we want the profitability index to be a higher number. A higher number is better. Okay. So we're just going to finish this LOS with one quick practice question. An investment of $20,000 will create a perpetual after-tax cash flow of $2,000. The required rate of return is 8%. What is the investment's profitability index? A, 1.08, B, 1.16, or C, 1.25? Okay, the correct answer is C. And they just put a little twist on it here because it's a perpetual cash flow of 2,000. So that might trip you up a little bit. But the calculation for the present value is just going to be the 2,000 divided by 0.08, the required rate of return, and that's going to give you a present value of 25,000. Okay, if I just bring up my calculator very quickly, it's just 2,000 divided by 0.08, and that's the present value, 25,000. Okay, so again, I just brought up the formula here, the present value of the future cash flows divided by the initial investment. The initial investment is 20,000. So 25,000 divided by 20,000 equals a profitability of index of 1.25. So the correct answer is C. Okay, that's the last slide for this LOS. Thank you.